Hey, here we are, and as you can tell, we've done a little bit of work here, and so let's zoom in and take a look. We've got our cell, and if you notice, I've got an acrylic housing so we can see through and check out what's going on with the cell. Up here we have a DC amp meter, analog. It was like $4 off of eBay, so I had to pick that up, and because I still don't know how to do that digital meter thing. We still have our dual bubbler. Putting that on hold right now because actually I've been working on the heat problem, and we still got the reservoir and our pump. Like I was saying, there were some problems between the cell and these terminal lugs, and basically the way I came about knowing that was on graveyard shift I had about 8 hours where I had to stay awake, and so I thought about HHO in my system. So I was wondering that since the 5/16 bolts here that are used to go through the PVC lid and the cell are pretty dense metals, pretty solid 5/16 inch metal, and I looked at the metal, and if you notice that is like really thin, and I figured, well, I think part of the problem is that either this piece of metal is not a good conductor and it's not as good of stainless steel as I thought it was. And again, this was from a stainless steel old drywall mud pen that I had. So I went to Lowe's and I found a piece of metal, and basically that is a lot bigger and a lot thicker, and let's see if we do a little comparison there. If you can see, yeah, it's definitely a lot bigger. So after much bending with wrenches and stuff like that, I made a long contact that would actually go to the top of the lid and go down to the cell itself. And so if we look there, that's what we see. And it's pretty sturdy. And then I ran it up, and yesterday I ended up running this thing for about 2.5 hours, and I was able to put my finger on the bolts and it was good to go. So anyway, a little bit about the cell. I went to try to find some more 316L gang switch plate covers, and the only thing that they had left were, at both Lowe's and Home Depot, are the 302 stainless steel, which is really kind of crappy. So, and that's what those two are on the end that I cut those off, and I was trying different cell variations, but I added these two on, so instead of having 8 plates on each side, it now has 10 plates on each side. And so we're going to take a look at that. The water here is only tap water and sodium hydroxide, and so let's take a look at what we got. And again, we've got our pump, and there you can take a look at the pump, and it's circulating the water. It's getting rid of some of the bubbles. It's not any type of reaction that we have yet. Just getting air out of the system, and if you notice, there's some little bit of gunky stuff, and that's just for the fact that it's tap water. Regular tap water. And so now what we'll do, we got a fully charged battery, and we're getting some pretty good production. And if you notice, we're running about 12 volts. Yep. And then we're running at 20 amps. And we're doing pretty good. And I've noticed when I added those 2 other plates on each side that actually we're running about 11.98, 97, 95, 90. When I added these 2 sets of plates on the sides, I found out that it does kind of dissipate the heat and drops the amperage, because instead of having 20 amps that I have now, it was down to like 12 or 14 amps. So anyway, this is the cold cell. This is it running, and everything's running well. And again, I told you I ran it for about 3 hours yesterday and checking it out. And so it's running pretty good. And here's one thing that I did find out is that if we turn the pump off, there is no difference in production. Matter of fact, when I did the displacement test with the cell and with and without the pump, that I ended up getting the exact same numbers. So I don't see the pump, and I ran about like 10 different tests, 5 with just the cell, and then 5 with the cell and the pump, and there was no difference in production. So I definitely proved to myself that a pump does not increase production of HHO or hydroxy gas, but all it actually does is just help circulate your electrolyte and help keep your cell warm. But what's really cool is, again, that high-speed metal, that metal bar, and I probably got something a bit that was too thick. I could probably even go down and gauge a little bit more. But that did definitely fix the problem as far as my terminals heating up. So, but yeah, that's how it works, and it's good to go, and we're having some fun. So hopefully, now with this, we'll be able to put this into the housing. Here's the original housing that I had that's going to go in the vehicle. And again, all I did was just drill out and put those connectors on there. And again, we'll have to put some type of tube on here for like an air hose or an air line, so that way we can fill up the reservoir all the way. Because if this is all hooked up and you just pour water in here, there's no way for all the electrolyte to go into the cell, and you got to have some type of breathing tube or something. So anyway, that's the cell, and it's doing pretty good. And actually, I'm probably not going to throw this in my vehicle, because I had ordered some 316L stainless steel plates, in which I'm going to change out, instead of using switch plate covers, use these 316L plates that I ordered, and we're going to do some tests on that. And so we'll do the original SMAC configuration with 8 sets of plates on each side, and again, the negative is in the middle and the positive is on the outside, and then that's basically it. So, and you can see it's producing some good gas. Let me take it off there and run this through, clean it up a little bit. I'll give you a parting shot of just the gas. Is it okay? See if you give you one parting shot with try to get all the bubbles out of there. I'll see if we can give you a shot. So, ready, set, go. And again, that's pouring out some good stuff, about 500 milliliters in about 40 seconds. So, again, with those 2 extra plates, it's a little slow, but hey, when you go back to the original configuration, we'll check it out and see what happens. So anyway, that's the deal with the system back there, and some of the improvements that we're going to do. Also going, when we get the 316L plates, we're going to get some this heat shrink, which is good up to about 600 volts. It says 105 degree Celsius, and it's 4-inch heat shrink. And this stuff is some pretty heavy duty stuff. I don't know if you can see how thick that is, but this stuff is some real good heat shrink. This will definitely help keep the cell warm, and maybe it'll help focus the electrolyte through the cell, going through the bottom of the cell up to the top, and we'll see how that works. trying to do almost everything you can to get a dry cell without actually being a dry cell. And again, maybe I will one of these days. So anyway, that's it. The cell's working good. I'm going to rebuild it, reconfigure. Cheapy metal, bad. Thick metal, good. Lowe's and Home Depot 302 stainless, bad. 316L, good. So anyway, that's it, and we'll catch you later. Peace.